Hello everyone, welcome to the lecture series on basics of electrical engineering. In this video, we're going to see parallel AC circuits, the theory behind parallel AC circuits, and few of the worked examples with respect to parallel AC circuits. So let's get started. So parallel AC circuits. Before starting off with parallel AC circuits, this requires a prerequisite. You have to know what is the response of an inductor, capacitor, and resistor when they're connected to an AC supply. Series RL, series RC, series RLC response when they're connected to AC supply. So all of these six videos description link is provided in the description. So in case you haven't watched that, please do watch it, and this concept will be based on the extension of whatever is being taught in the previous videos. So once that is done, so we will be starting off with parallel AC circuits. We all know with respect to parallel AC circuits, the current will divide and the voltage remains same. So when we say parallel AC circuits, it doesn't mean only Z1 and Z2 will be there. There can be n number of impedances that are connected in parallel. However, the supply voltage will remain constant, and circuit is said to be connected in parallel if they are connected between the same 2 points over here. If you mark this as A and B, these are connected between the same 2 points. So what are the conclusions that we are going to draw with respect to parallel AC circuits? So basically, we will first try to find the overall impedance of this particular circuit. So that is given by 1 by Z bar is equal to 1 by Z1 bar plus 1 by Z2 bar. That is based on two resistors connected on parallel, like 1 by R is equal to 1 by R1 plus 1 by R2, or Z is equal to Z1 Z2 by Z1 plus Z2. So based on that, this is the equivalent impedance 1 by Z bar. So this can be represented in terms of Y bar is equal to Y1 bar plus Y2 bar. Consequently, Y bar is nothing but the reciprocal of impedance 1 by Z bar. So Y bar is called as the admittance, and it has both real part and imaginary part. Just like the way you have impedance in terms of real part, that is the resistor, and imaginary part, that is J into XL or XC, that is the reactance. So based on that, similarly you will be having admittance to be having real part and imaginary part. So Y is called as the admittance, and it is the reciprocal of the impedance. So this is the real part and this is the imaginary part. The real part is called as conductance, the imaginary part is called as susceptance. Both are measured in terms of mho or Siemens, so you can represent in either one of the units with respect to the problems that you're solving. So once this is done, one of the most important criteria, or one of the most important parameter in a circuit, is current. So what happens to the current in case of a parallel AC circuit? So the current in a parallel AC circuit can be found as the phasor sum of the branch currents. So it's very clear, if you apply KCL for this particular circuit, so you'll be getting I bar plus I1 bar plus I2 bar. So the reason why we are representing in this particular form is because sum of currents entering the node will be equal to the sum of currents leaving the node in case of a KCL explanation, Kirchhoff's current law. Or in other words, you can also say algebraic sum of currents in a closed loop or a mesh is equal to 0. So that's the reason why we have this equation. So I bar is equal to I1 plus I2 bar. So if you have n number of currents, you'll be adding all the currents with respect to them. So very important formula with respect to parallel AC circuits in order to solve any number of problems. So all these important conclusions that we are deriving, please do make a note of them in a separate place, so that it will be really helpful for you to solve the problems. So we'll be drawing two conclusions. We want to find the conductance and susceptance with respect to series RL circuit and series RC circuit. So our note 1 is for series RL circuit. We know the impedance Z bar is given as R plus J into XL. So Y bar is nothing but the reciprocal of impedance 1 by Z bar. So Y bar can be represented as 1 by R plus J into XL. Substituting the value of Z bar over here, you will be getting in this particular fashion. Now what I'll do is I'll multiply numerator and denominator by R minus J into XL. So when I multiply, you will be getting R minus J into XL in the numerator divided by R square plus XL square. So once that is done, I will be splitting the numerator terms, that is R by R square plus XL square. This is one equation, and minus J into XL by R square plus XL square. I will be writing this separately. So the reason why I am writing this is because I can represent in terms of G and BL. So over here, G minus JBL is what we can write it. So this is nothing but the conductance, and this is the susceptance. So equating the real parts and imaginary parts, you will be getting G as this and BL as this. So the reason why we want this is in case they give you a problem on parallel series RL circuit, and they ask you to find the conductance, or they ask you to find the susceptance, you will be able to directly apply this formula and solve them. Or you can also go on with the analysis method of deriving what is the value of G and BL. One important observation: Z bar is equal to R plus J into XL, but here it is Y bar is equal to G minus J into BL. So it is quite contrary. There is a negative sign with respect to J, and there is a positive sign with respect to Z bar. So what does that mean? I will be considering an impedance triangle, R plus J into XL. Since it is Z bar is leading with respect to R and in this particular impedance triangle, if you see Z bar is in this particular direction because the quantity R plus J into XL is there. Now if you have to write the admittance triangle, how do we represent it? G is represented here, BL is represented here, and Y, which is nothing but the reciprocal of Z, is in this particular direction because you have the quantity G minus J into BL. Similarly, when you had R minus J into XC, we used to represent Z in this particular direction, isn't it? So similarly, we will be writing Y as in this Y will be in this particular direction, and it is the admittance triangle. So just for sake of understanding, I have shown these two triangles for you, but as a whole the concept remains the same with respect to series RL circuit. So with respect to series RC circuit, we know Z bar is equal to R minus J into XC, Y bar is equal to 1 by Z bar. Again, I'll substitute the value of Z bar to be equal to 1 by R minus J into XC. So multiplying numerator and denominator by R plus J into XC, you will be arriving at this particular equation, that is R plus J into XC by R square plus XC square. Our next step is to separate the numerator and separate the denominator terms. So R is separated with respect to this term and JXC is separated with respect to this term. So it is written in this particular fashion. So once this is done, we can say it is in the form of G plus J into BC, isn't it? So where G is nothing but this value and where BC is nothing but this value. So we have found the conductance and the susceptance in case of a series RC circuit. So what is the major difference here? Z bar is with respect to R minus J into XC, Y bar is G plus J into BC. So one common observation, if Z bar is minus, it will be plus here. If it is plus, it will be minus here. One common observation with respect to problems. And one more observation is, we know that impedance triangle for a series RC circuit, Z bar is in this direction. Similarly, the impedance will be in the upward direction. It's quite contrary to what is being explained with respect to series RL circuit. So I hope this concept of analyzing the conductance and susceptances for a parallel AC circuit is clear. So once this is done, we'll be looking at 6 different examples, and trust me, after solving these 6 different examples, 90% of the problems with respect to parallel AC circuit, you will definitely be confident in solving it. So alright, so let's get started with respect to the problems. So work at example 1. A coil having a resistance of 50 ohm and inductance of 0.02 Henry is connected in parallel with a capacitor of 25 microfarad across a single phase 200 volt 50 Hz supply. Calculate the coil current in the coil and capacitance. Calculate also the total current drawn, total power factor, total power consumed by the circuit. So they have asked us to find a lot of things. First step is to write the circuit diagram, draw the circuit diagram. R and L are connected in series, so having a resistance and inductance they have told, and this is connected in terms in parallel with a capacitor of 25 microfarad. Both of them are connected to the same supply. I is the current flowing. They have asked us to find the current flowing through the coil, that is I1. They've asked us to find the current flowing through the capacitor I2. They've asked us to find the total current, that is I, and power factor, total power consumed by the circuit. So we will be going step by so first step is to write the given data, whatever is given we have to write it, and once that is done, step 1 is to determine the current in the coil and capacitor. We'll be finding the value of I1 and I2. For finding that, we need to know the impedance offered with this path and the impedance offered with respect to this path. So how do we find that? So Z1 bar is equal to R plus J into XL if you are applying Z bar for this particular uh, network, and if you are applying with respect to this particular portion, Z2 bar is equal to minus J into XC, isn't it? So our first step is to find the value of XL and XC, and then we'll be able to find Z1 and Z2, and once we know that, we'll be able to find I1 and I2. So XL is equal to 2 pi FL. Substitute the value of the inductor given, you will be getting 6.28 ohms. So once you find the value of XL, our next step is to find the value of XC, which is given by 1 by 2 pi FC. So 1 by 2 pi into 50 into 25 into 10 power minus 6, according to the substitutions, you'll be getting 127.32 ohms. So once you have found the value of XL and XC, you can find the value of Z1 and Z2 bar, isn't it? Because they have given R value, so we'll be able to substitute it over here, and we can find Z1 bar and Z2 bar respectively. So I've considered the network again just for understanding. Z1 bar is equal to R plus J into XL. Substitute the value of R, substitute the value of XL, and represent them in polar form, and necessarily if you want, you can represent them in the rectangle form as well. So you'll be getting 50.39 at an angle of 7.16 degree. Z2 bar is equal to minus j into xc bar, that is equal to minus j 127.32. This is in rectangular form, convert them into polar form. So 127.32 at an angle minus 90 degree. This is the value of Z2. Once you know the value of Z2, Z is nothing but uh, you will be able to find the value of Z. But before that, supply voltage 200 at an angle of 0. Since it's the angle is not specified, you will be assuming it to be equal to 0. So I1 bar is equal to V bar by Z1 bar. So substitute the values, you will be getting 3.97 at an angle of minus 7.16 degree amps. So I2 bar is nothing but V bar by Z2 bar. Since the voltage remains constant, we can directly write V bar by Z2 bar. Substitute the value of V bar and substitute the value of Z2 bar that is found earlier, you will be getting 1.57 at an angle 90 degree. So once this is done, to determine the total current, we can do in two methods. You know Z1 bar, Z2 bar. You can find Z bar is equal to Z1 bar, Z2 bar by Z1 bar plus Z2 bar, and then find I by V by Z. Or you can do it in this particular method as well. I bar is equal to I1 bar plus I2 bar. That is the according to KCL, the algebraic sum of currents in a closed loop is equal to 0. So that is equal to 3.97. Substitute the value obtained here, substitute the value obtained here, you'll be getting 4.08 at an angle of 15.27 degrees. So be very careful while substituting all these values in calculator, because the steps are pretty simple. The only place you go wrong with respect to AC circuit problems is that while substituting and solving them in calculator, you might go wrong. So be very careful, do it slowly with respect to solving these type of problems. Next step is to determine the power factor. They've already given the current. We have found out the current in polar form, that is 15.27. So in order to determine the power factor is defined as the cos of the phase angle difference between I and V. So V is at 0 degree and I is at 15.27. So the phase difference is 15.27. So cos of 15.27, you will be getting 0.965 lagging power factor. So the reason why we will be saying it to be equal to lagging power factor is because XL value is greater than XC, that is it is lagging in nature with respect to the circuit. Step 4 is to determine the power consumed. In case they ask you to find power consumed or power lost in the circuit, it is always the active power. That is already explained in all my previous videos. Emphasis is given on power consumed. So with respect to power loss or power consumed, it is always the resistive component consumption of power. Due to the resistor, the power is consumed. So that is the reason why we call it as active power, and it is given by the formula VI cos phi. So 200 into 4.08 into 0.965, that is 787.44 watt. So very important conclusion with respect to the power consumed. So we have found out all the parameters with respect to the given problem. We'll go into our next example, that is example 2. So they've given us a circuit and they've asked us to find the supply current, the current in each branch, and total power factor. So the problem looks pretty simple, but there are a certain series of steps that you need to follow. So once you have solved, you will be able to solve and understand this problem. Next problem will be very simple for you. So to determine the supply current and current in each branch, so how do we proceed with respect to it? Our first step is to determine XL, that is given by 2 pi FL. You'll be getting 2 pi into 50 into 0.12. Find the value of XL, find the value of XC by 1 by 2 pi FC. Once you have the value of XL and XC, you'll be able to find the value of Z1 bar and substitute the values obtained, and you'll be able to find Z2 bar as well. So you'll be getting these values. So once you know the value of Z1 bar and Z2 bar, we know Z equivalent is given by Z1 bar by Z2 bar by Z1 bar plus Z2 bar plus Z2 bar. So substitute, solve them, represent them in polar forms and solve them. Be very careful while substituting them in calculator. You'll be getting Z equivalent to be equal to 62.11 at an angle 53.63 degree. So this is Z equivalent. So how do we find the supply current? So I is nothing but V by Z equivalent, isn't it? So we found the overall impedance offered by the circuit. We know the value of I current, the value we are supposed to find the value of I, but we know the value of supply voltage V bar. So I bar is equal to 200 at an angle 0 divided by 62.11 at an angle 53.63 degree. So substituting, you will be getting 3.22 at an angle of minus 53.63 degrees amps. So once this is done, they have asked us to find the current in each branch. So I1 bar, we can write it as I bar into Z2 bar by Z1 bar plus Z2 bar. This is by current division rule. If you have to find the current I1 flowing, it is nothing but the supply current into the current flowing through the opposite branch divided by the overall impedance offered by the circuit. So I into the current flowing, the impedance of the current flowing through the opposite branch divided by the sum of impedances. Substitute, you will be getting I1 bar. Similarly, we can follow the same method with respect to I2 bar, or you can do it in this particular way. We know I is equal to I1 plus I2. So I2 is equal to I bar minus I1 bar. Substitute, you will be getting 2.43 at an angle of 75.91 degree amps. So once you have found out I2 bar, we have found the branch current, we have found out the supply current. So now next step is to find the power factor according to the requirement. So power factor is defined as the cosine of the angle. So with respect to current, we know that the angle with respect to I is nothing but 53.63. Substitute it, you will be getting 0.593 lagging. So the reason why it is lagging is because if you observe with respect to this overall I, it is minus, so I is behind V. That is the reason why we'll be mentioning it as to be lagging. So, or in other words, you can say XL is greater than XC, and the nature of circuit is inductive. As a result, this can be called as lagging power factor. So this is how we will be solving these type of problems. So we'll go into our next problem, example 3. Calculate branch current I1 and I2 for the circuit shown. So pause this video over here and try this problem on your own. This is quite similar to the previous problem, in fact much simpler, because they've given us the value of XL and XC directly in ohms, so you'll be able to find it directly. So in case you're not able to solve this, continue watching this video and find how this can be solved. All right, so these are the given data. Z1 bar, Z2 bar is given. We'll be representing them both in rectangular and polar form. We know that V bar is 200 volt. So how we are saying that this is given? Z1 bar, we know that R plus J into XL with respect to 15 plus J into 31.4, straightforward. So I've taken this as given data. So up till this point you will be able to solve it straight away. Now our first step is to find the value of I1 bar. So can we write I1 bar is equal to V bar by Z1 bar by Ohm's law? So you'll be getting 200 divided by 34.8 at an angle of 64.47. You'll be getting 5.75 at an angle of minus 64.47 degree amps. Branch current I2 is nothing but V bar by Z2 bar. Again, substitute the value. You'll be getting 2.66 at an angle of 57.87 amps. So I guess this problem is understood. This is a very, very simple problem. Just to build up your confidence, if you solve this on your own, you'll definitely uh, be able to build a lot of confidence with respect to solving parallel AC circuits. That's the reason I gave one of the simple problems with respect to this. So example 4, two impedances Z1 and Z2 are connected in parallel across a single phase AC supply. That means they're clearly saying they're connected in parallel. That is a parallel AC circuit. Calculate current drawn by each branch, total current, overall power factor. Also draw the phasor diagram indicating the current drawn by each branch and total current taking the supply voltage as reference. So they've given us an additional concept of drawing the phasor diagram, and they've also told us to take supply voltage as reference. So very, very important points to be noted. So again, we'll be solving the problem by the same method that was indicated in our second example. So they've given Z1 bar at 30 at an angle of 45 and Z2 bar 40 at an angle of 30. So we'll be determining the current drawn by each branch. That is our first criteria. I1 bar is equal to V bar by Z1 bar. Substitute, you'll be getting 7.67 at an angle minus 45 amps. I2 bar is nothing but V bar by Z2 bar. Substitute the value of V bar, substitute the value of Z bar, Z2 bar, that is 45 at an angle of 30 degree. You'll be getting 5.11 at an angle of minus 30 amps. So once you have found out I1 bar and I2 bar, this is the first bit of the problem, that is current drawn by each branch is known. Now they've asked us to find the total current, that is nothing but I1 plus I2 bar. So we'll be adding I1 bar and I2 bar. You will be getting 12.67 at an angle of minus 39.01 degrees amps. So once you find I bar, our next step is to find the overall power factor. So cos of this angle, you will be getting the power factor, isn't it? So 39.01, it is lagging because I bar angle is negative. As a result, it is lagging. I is lagging with respect to V, and lagging is always determined, lagging or leading is always designated in terms of current. So I is lagging with respect to V, you'll be representing it as lagging. So very, very important point. If you don't mention anything, power factor of 0.777 does not give any significance. What type of the circuit it is. So in case of AC, you have to always represent lagging or leading with respect to power factor. Step 4 is to draw the phasor diagram. So it's very simple. They have told us to take V bar as reference. So this is how our phasor diagram looks like. So how do we draw? Taken V bar as reference, and we have found out the angle with respect to I1 bar, I2 bar, and I bar. So since all of them are in minus, I will be drawing them in the downward direction. If they are in plus, I'll be drawing in the upward direction. So initially, if you see, I1 bar is 45 degree lagging with respect to V bar, so it's written with respect to 45 degree, and I bar is 39.01 degree lagging with respect to V bar, so it is represented in this particular fashion, and I2 bar is 30 degree lagging with respect to V bar. So all of them are in the downward direction, represent the respective angles. Roughly, if you draw, it's more than enough. In case all of them were leading, then you have to draw in the upward direction, or if one is leading and one is lagging, depending upon the angle, you will be able to draw them. So this is the step that needs to be followed. This is an additional bit of solving how to draw the phasor diagram with respect to a given problem. That's the reason why this problem is taken. I hope this problem is understood. In case any questions with respect to this problem, feel free to reach out to me by typing in your questions in the comment section. So we'll go into our next example. Example 5. Two circuits A and B are connected in parallel to a 115 volt 50 hertz supply. They have given a single supply that is connected across two circuits A and B. The total current taken by the combination is 10 amps at unity power factor. So they have told the power factor is 1 and the current I is equal to 10 amps. Circuit A consists of 10 ohm resistor and 200 microfarad. So it is a series RC circuit. Circuit 1 is. Circuit B is a series RL circuit. So this is why I told you the importance of series RL and series RC circuit should be known. Only then we will be able to understand parallel circuits properly. Determine current, power factor, impedance, resistance, reactance of the circuit B. Only with respect to circuit B they have asked all these parameters. So how do we proceed? Our first step is to draw the circuit diagram. So they have told IA is the current flow. Let us assume IA is current flowing through circuit A and IB is current flowing through circuit B. RA and C is the RA is the resistance and C is the capacitance. RB is the resistance and XB is the inductance according to the circuit diagram. 10 amps is the current flowing through the circuit. The supply voltage is 115 volt, 50 hertz. Now we'll be writing in the given data, that is supply voltage 115 volt, frequency 50 hertz, high is 10 amps, power factor is given to be equal to 1 ohm, 10 ohm is the resistance, and the capacitance is equal to 200 microfarad. So how do we find the value of the current flowing through the circuit B? It's very simple. We'll be finding first we'll be finding XC, that is XC is equal to 1 by 2 pi FC. Substitute the value, you'll be getting 15.92. Once you know that, you will be knowing the value of ZA bar, that is 10 minus J into 15.92. Why it is minus J? Because it is a series RC circuit. In case of series RL circuit, it is plus J. So you'll be getting 18.8 at an angle of minus 57.87 ohms. So once we have found out the value of ZA bar, can we not find the value of IA bar? So IA bar is given by V bar by ZA bar. So substituting the value of V bar and substituting the value of ZA bar, you will be getting 6.12 at an angle of 57.87 amps. So the reason why we are doing and finding IA bar is we need to find IB bar. So how do we do it? We know I bar. So I bar is equal to IA bar plus IB bar. So IB bar can be written as I bar minus IA bar, isn't it? So substituting the values of I bar, that is 10 at an angle of 0 minus 6.12 at an angle of 57.87, you'll be getting 8.5 at an angle of minus 37.54 amps. So we have found out the current I bar with respect to circuit B. Now power factor is asked. So power factor is with respect to circuit B means you have to take this angle's power factor. IB angle is nothing but minus 37.54. So cos of minus 37.54 is what you have to take. So that is cos of 37.54, you'll be getting 0.79 lagging because angle with respect to IB bar is negative. So you'll be representing it as lagging over here. So step 3 is to determine the impedance of circuit B. So how do we find the impedance? ZB is equal to V bar by IB bar. So we'll be substituting, we know V bar, we know IB bar given. So that is found out. So we'll be substituting all of these. You'll be getting 10.73 plus J at an angle of 8.24. So over here now they have asked us to find the real part and imaginary part, that is the resistance and the reactance. So over here it's very clear, real part is nothing but the resistance for with respect to the impedance, and the imaginary part is the reactance. So XB is nothing but 8.24. So we have found out all the parameters that is asked in this question, and this is how we approach these type of problems. I hope this problem is understood. So let's go into our next problem. That is example 6. Two impedances 12 plus J16 at and 10 minus J20 are connected in parallel across 230 volt. So what does this imply? This is a series RL circuit. How did I identify 12 plus J and this is 10 minus J? That means minus J will come for a capacitive network and plus J with respect to inductor. So series RC and series RL are connected in parallel across 230 volt. Find kilowatt, kVA, kVAR and power factor. Kilowatt is nothing but the active power, kVA is nothing but the reactive power. This is the apparent power, kVAR is the reactive power. So we will be proceeding with the problem. We'll be representing the circuit diagram, that is Z1 and Z2 are connected in parallel, and we will be writing in the given data at the first place. Z1 bar is given, Z2 bar is given, V is given. So our first step is to find the kilowatt. So first for that we need to know what is the total current flowing. So I1 bar is equal to V bar by Z1 bar. So that is given as 230 at an angle 0 divided by 12 plus J16. You will be getting 11.5 at an angle of minus 53.13. So we'll be similarly finding I2 bar. Substitute, you will be getting 10.29 at an angle of 63.43 amps. So once we find I1 bar and I2 bar, now we can determine all these parameters straight away. How do we do that? The real power, that is with respect to branch 1 they have asked. Each branch they have asked us. So we'll first find out with respect to branch 1, and it will be similarly followed with respect to branch 2. Active power, kilowatt is with respect to watts or kilowatts or anything, it's always active power. So from the units we can identify what type of power that we are supposed to find. So P1 is equal to VI1 cos phi 1. Substitute the value of VI1 cos phi 1, you will be getting 1.59 kilowatt. Next step is to find the apparent power. Apparent power is nothing but the product of voltage and current according to definition. S1 is equal to V into I1, that is with respect to branch 1. Substitute, you will be getting 2.65 kilovolt ampere. So once this is done, Q1 is nothing, kVR is nothing but the reactive power, that is given by Q1 is equal to VI1 sin phi 1. So substitute, you will be getting 2.12 kVAR. So what is the power factor of each branch? So from this particular problem, we can say I1 bar is associated with the current of 53.13 angle with respect to I1 bar. So cos of that angle will give you zero point 0.6. Why it is lagging? Because it is minus with respect to the voltage. It is lagging with respect to the voltage. That's the reason why we'll be mentioning lagging power factor. So whereas in case of the other one, branch 2, it will be leading power factor because current is leading with respect to voltage, that is 63.43 amps. So now our step 2 is to determine kVA, kilowatt, kVA and kVR of and power factor of branch 2. How do we do that? P2 is equal to VI2 cos phi 2. Substitute all these values, you'll be getting 1.06 kilowatt. Similarly, S2 is equal to V into I2. You'll be getting 230 into 10.29. You'll be getting the value of 2.37 kilovolt ampere. And Q2 bar is equal to VI2 sin phi 2 bar, that is equal to 230 into 10.29 into sine of 63.43, that is 2.12 kVAR. So not necessarily they should be represented in kVAR, but in the question they've asked us what is the kilowatt, what is the kVA rating, what is the kVAR rating. So for that purpose we are representing it in this particular fashion. So once this is done, they've asked us to find the power factor of the circuit branch 2. So cos of phi 2 is nothing but the angle with respect to I2. So that is 63.43 and it is positive. That's why it's represented as leading. So you'll be getting power factor of 0.447 leading. So this is how we solve problems related to parallel AC circuits. I hope this has given you enough confidence in order to approach these type of problems. In case you have any questions, feel free to reach out to me by typing in your questions in the comment section below. If you like this video, please do like it, share it and subscribe to our channel for regular updates. Please keep supporting. Thank you.